Second week with Perl and database. The first thing we have to do in this period is to go over a couple articles on references, which are pointers. DBI makes use of pointers, so we have to learn something about it. It will also come in handy, of course, for uh, OOP or object-oriented programming coming out soon. So the first article, Understand References Today, is right here. The the problem which is described in this article is this. We are interested in storing cities in states. Now, New York and Albany both are in New York. And if we want to use a hash to store this type of information, we need references because, as we know, if we have one key for a state, New York, here in a hash, and we want to store two cities, we can't do it presently because we can only store one scalar variable uh, as associated with a key. So what we're going to do now is we're going to store one scalar variable, but this time it will be an address to an array where we can now store as many cities as we want on one key of a hash, in this case New York, and which demonstrated here. We want one key Illinois under which we have an array, Chicago, Evanston, and Springfield, and so forth. The solution. Well, first, before we find the solution, of course, we're looking at the syntax for references. Here's an array, and if we're interested in only the address of the array or the actual byte or a series of bytes which represent the location of this array in memory, then we put a backslash in front of it, and you can store this address in a regular scalar variable. In this case, we can call it array reference. This name that makes no difference. Or we can also store the address of the first byte of this structure hash by putting a backslash in front of it and storing it under a scalar. Next, we can take this reference to an array and transfer it to another scalar variable, or we can take the reference to the hash and transfer it to an array element, and we can take this element and transfer it one more time to a scalar variable. This is rule 1, how you create a reference out of an existent variable, whether it be an array or a hash, or anything else for that matter. Rule number 2, you can create anonymous arrays or hashes. What you do is you take a list, any list that you can create on the fly. This is usually done after your program is running. And let's say you want to create an array out of this list. You don't have a name for it, so all we need is to surround this list by square brackets. This syntax simply returns a pointer to where this list inside of the square bracket lives in memory. Now we have a reference, and we now have access to any of this data as an array. Same thing with a hash. If you have a legal list of key value, which now of course create a hash, you surround this list with curly braces, and that returns a pointer to where this information lives in memory. And we can capture this on the left with a scalar variable. So the references we get from rule 2 are the same kind of references that we get from rule 1. So same thing, right? Here we are creating a list, and this is an array of 3 numbers, 1, 2, 3, and we store that in this reference. You could also create an array and give it a name, as we normally would do before a program runs, and now you can take the location of this array in memory and pass it on to a reference. So these two would be identical at this point. um, to use these references or get back to the value that these references point to, they have a use rule 1. And if a reference contains a reference to an array, then we can put the we can surround this reference by curly braces, and that gets you back to the content of that reference. For instance, we have a reference here that we created earlier, right? This is a reference to an array, and what we do is we surround this by curly braces and 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 place the @ sign in front of it. This is exactly the same thing as an array. You can look at this as any array name that we previously had can now be replaced by this syntax, curly braces uh, containing the reference to an array, an anonymous array, or whatever array we have, right? So this is the same thing. Reverse array A would be the same thing as reverse array sign and the curly braces and the reference. Here it gets a little more complicated. We have an array, third item here, or fourth item, index 3. So same thing here. We replace the A by a reference, which we call, by the way, dereferencing. We are dereferencing a pointer. We're getting to the content of this pointer, and now that we have the content to it, we can look at element 3. Same thing, you can place a value into element 3 of dereferenced pointer to an array. And of course we have a $ in front of it because we're looking at a scalar value. Same thing with a hash. You take a reference to a hash, you can dereference it with the same curly braces, but now since this reference is a reference to a hash, then you can use the hash symbol in front. And we use it the same way. Now we're going to look at the scalar of a dereferenced hash pointer, and we are accessing, and then we're accessing its key, red, and we are putting 17 into it. Let's see. So now it explains the rule 2. Another way to look at this, because it's a little bit hard to read as it is that now we can use a pointer and use the pointing syntax, which is nothing but those two symbols. So you want to reach index 3 of a pointer to an array, we can use this syntax. It makes things a lot easier. Same thing with a hash. This is a pointer to a hash, and we are dereferencing that pointer to its key. And now we're getting the value of what's inside of the key, red, inside of this hash. Here's an example. Here we are, this is a regular, we are initializing a regular array called A. You notice this, the simple parenthesis around here. However, inside of this array here, we have 3 elements, right? Because they're separated by commas. But note that each element is now an array or a list. However, that list is surrounded by square bracket. Therefore, what this is returning is one pointer. This is the address of where these 3 numbers live. And here's the address of where 4, 5, 6 live, and same thing with this. So we have 3 addresses that are stored as 3 elements in this array. Therefore, to use this data, of course we could say, now what are we getting here? Array element 1 or index 1 of array A. What is it? Well, it is this one, correct? Use rule 2 says that we can write this element 1 or index 1 of this of array A is a pointer, and we can dereference it to index 2, which means array 1 is this reference, and it is referencing, it's a reference to an array of 4, 5, 6, and the second element happens to be 6. Make sure that you understand the rest of these examples. Alright, let's look at one more here. We saw that one, and we can look at the 0 index of A is of course 1, 2, 3, and we're looking, and this is a pointer, contains a pointer. This element is actually a pointer to an array, and that array dereferenced, this pointer dereferenced, is going to be looking at index 1, which is number 2. So this is it for this article. You can keep reading it. The second article here demonstrates some other syntax for references as well, and some review. So let's go look at the information right away. A little review. Okay, so now we put Papa in me. Then we take me and we get a reference to that and save it in this scalar. The next, we print this. Now here we're printing just $me just to as a debug statement, and here we print me, which is nothing but Popeye, right? Now the value of, again, ref, which is our reference, which should represent an address, and here we are printing the address, and here, folks, how an address looks like. This is what you'll get. It will when you print a reference, Perl will of course give you the address itself, which is in this case this address here of 4 bytes, BAA. Well, it looks like 8 bytes. I mean 5 bytes, and it will tell you what type of reference. This is a reference to a scalar, and indeed me is nothing but a scalar. Next page, we are now going to dereference this. What we want to do, of course, is to, once we have a pointer to some data, we want to be able to access this data directly from the pointer, and we learn how to do that, and we're going to try it out right here. The value of let's see, the value of the reference variable is, and here's another syntax. Instead of using the curly brace like we did before, we can also repeat the symbol for the scalar variable in front, and it will be the same thing for arrays and hashes. So here we are getting Popeye because we are dereferencing this reference ref, which is nothing but a pointer to the variable me. Next, here's another example of a simple array, correct, and now a simple hash of animals, and here we are taking the address or the reference of friends and storing it in ref, and here we're taking the reference of this hash and save it in FER. We are printing ref, we are printing fur, and here we're printing a dereferencing of the index 0 of this array. This is a reference to an array. We are dereferencing it, and here we are dereferencing this hash and accessing the key Mickey. And if we try that, getting the reference itself for an array, it will say array in the front, and if you have a reference to a hash, it will tell you so, that is a hash. And here we are referencing the values of these dereferenced pointers. Another type of pointer that you can create is one from a subroutine. Here's a subroutine called Who Am I? and of course we can just do whatever we want inside of this routine. But you can take this routine, who am I, and you can also have a reference to it. You can also uh, grab first the address in memory of where this subroutine lives, and you can save that in a scalar variable, and now you can access uh, the actual routine of this reference by adding in front of the scalar variable which contains an address, right? You can dereference it by putting the subroutine symbol in front. This time the name of the reference for Perl will be code. Next, review on the anonymous idea here, where this array friend is really exactly the same thing as this one. Instead of creating a list and storing it in an array, you can also create this list and bypass the name of the array by simply returning the address of where this list live and placing that directly into an array. An array reference. Same thing here has been done with a hash, and I think there's nothing else in this that's important. So that's it, folks. Be sure that you read those articles, understand them, and understand the syntax for referencing arrays and hashes in particular, and how you can dereference that information back into their values. Thank you very much.